Now we're going to get started. Thanks for coming to this session. We have a little over an hour to talk about analyzing financial time series data with MongoDB Atlas. So we have one of our MongoDB solution architects here. He came in all the way from Dubai, so probably one of our most jet-lagged folks here. Very impressive on our side. And we have a lot of content to cover. Feel free to ask some questions. He's also offered to stay afterwards to answer individual questions if you're interested. So without further ado, please welcome Fuat Sungar.
Good afternoon, everybody. Welcome to our session. So I would like to start with a question. Show of the hands if you have ever invested in financial markets. It could be cryptocurrencies, stock market, at the wrong time. Yeah, thanks for being transparent. So I did this many times, unfortunately, and therefore I decided to build an application. So my plan was processing historical data of the market, price data, and then estimate what might happen in the future. However, sooner I realized that it's not easy because there are many pieces need to be implemented from scratch. They need to be integrated between each other in a scalable, efficient, high available way. So my name is Fuat Sungar. I'm working as a solutions architect at MongoDB. And today, I will walk you through what I built and how I built an end-to-end application by using only the features of MongoDB Developer Data Platform. This is our agenda today. First, I will show you what I built. And in the second section, I will walk you through how I built this. And in the last section, I will try to explain what kind of features you can implement. So let's get started with the first section. What I built? I built an MVP, minimum viable product, that loads cryptocurrency data into MongoDB Atlas almost real time. There's a web interface that provides a mechanism to execute some well-known technical indicators, financial technical indicators such as simple moving average, RSI, and etc. So if you don't know any of these technical indicators, don't worry, I will walk you through so you will have better understanding. And also you can define some kind of rules. So if, for example, given cryptocurrency price reach to some point, then automatically you can take some action. Okay, let me show what I built. This is our web interface. So basically there are two main pages, currency analysis and rule definition. So first you choose a cryptocurrency to analyze it. So here I choose Bitcoin. And I can also see some example of it, example data. So we have three fields, time, symbol, and price fields, price information. And every few seconds, we load data into MongoDB Atlas cluster. Here we have some filtering. So we just only get the last hour of data. And here, we can group our data by different time resolution. So we have second-based data, but we can group the data to different time resolution. And we can choose some technical indicators. Here I provide some parameters, okay? And if you don't know any of this, don't worry, I will walk you through in the next slides. Then hit the button, Show Charts. So first, we have a Candlestick Charts here, so we can see the trend, okay? And after that, you can see the technical indicators. So for example, here the RSI, we see the RSI chart, MACD chart, Stochastic Oscillator chart. And at the bottom, we see the generated aggregation query, okay? So basically, based on the criteria that is provided by the user, under the hood, I generate an aggregation query and execute it, and get the data to the front end and visualize it. In the second page, we can define some rules. So for example, here I provide a name for the rule, okay? Then I choose the cryptocurrency. So I would like to define a rule based on Bitcoin currency. And I choose the interval. So I would like to group my second base data into minute-based. I provide here two things. First, I provide how many data points, previous data points need to be calculated for the method. So I have, for example, moving average, exponential moving average, and relative strength index. And based on the method, previous data points need to be, it's going to be considered for the calculation. So then I provide my condition here, and that's it. So basically, I'm able to define a rule that if last 10 minutes of Bitcoin price, moving average of the price value, if it is greater than 30,000, we can take further actions. Okay? So that is our application. And here I will explain high level what kind of features I use for this end-to-end application. So at the right-hand side, you see exchange data provider. Basically, this I'm using cryptocurrency exchanges, and I'm able to retrieve cryptocurrency market data, price data, almost real time. And in the middle, you see MongoDB Developer Data Platform. And at the left-hand side, you see a client device. Okay? So everything starts with Atlas functions. Atlas functions, in Atlas function, I make REST call and retrieve market data, price information. And this function is scheduled, and it is executed every minute. And we load the data in MongoDB Atlas cluster time series collections. And we have actually a single page application, and we host this application, React application, in app services static hosting that is available in MongoDB Atlas. Whenever the client visits the URL, then he can see the application, and with the Run Web SDK, they can access MongoDB Developer Data Platform. So, for example, in the client side, you can execute some Atlas functions and process the data in the front end. So this is our high-level architecture, and in the next section, I will look into all of the components here. All right. So in this section, I will explain how I build. So first, I will explain how I retrieve data from the exchanges, cryptocurrency exchanges. Then I'll explain how I use time series collections. And I will explain how I generate the candlestick charts. Then explain technical indicator implementation, how the financial technical indicators like RSI can be calculated in aggregation framework. Then I will explain how I embed this logic in Atlas functions. Then I will explain how I use Realm WEB SDK in the client side to access MongoDB Developer Data Platform. And finally, I will complete this section with hosting part. Okay, let's get started with retrieving data from the exchanges. So I use two well-known cryptocurrency exchanges, Binance and Coinbase, and both are providing API access to retrieve market data, okay? So let me show you quickly how does it work. So here you see a REST client, Postman, and I'm actually accessing this URI, Binance, and I'm able to retrieve all of the cryptocurrency, available cryptocurrency, and along with price information, okay? And for other cryptocurrency exchange, for the Coinbase, I'm specifying which cryptocurrency I'm interested in, then I'm able to retrieve price information. All right, so typical three-tier application. At the bottom, we have database layer. We are using MongoDB Atlas. And in the front end, you can have multiple applications front-end application, desktop application, mobile application. And in the middle, you will need a back-end application, right? So for this purpose, you can develop an application from scratch. It could be Node.js application, Python application, whatever your preferred language is. Or you can use a serverless platform like MongoDB Atlas App Services. Atlas App Services is a serverless backend as a service platform that provides many functionality for your modern applications like authentication, triggers, schema definition, GraphQL, data API. Maybe you have already attended some session and you have some understanding. I actually use MongoDB Atlas App Services heavily in this application. So how you can create an application in Atlas App Services? You can have an account, MongoDB Cloud account, cloud.mongodb.com. You specify the data source. You would like to connect your application. It could be MongoDB Atlas cluster. It could be MongoDB Atlas Data Lake, and also serverless database as well. So you have backend serverless application, and you can utilize existing data sources available in MongoDB Atlas. You give it a name. Our application name is ticker analysis, and you can choose a deployment model. It could be deploy globally or locally. And our application is going to be ready immediately, and there are many features you can use for this application. All right. So Atlas Functions. Atlas Functions provides a way you can implement your logic in Atlas App Services. So for example, you can access database, you can fetch data, process further, and store it again in database, or you can make HTTP calls, you can do REST calls, etc. And it is natively compatible with MongoDB development platform capabilities. Atlas, you can access Atlas clusters, data lake, search, time series collection. So in this part, I will show you how I use Atlas function to retrieve market data. So here I have one Atlas function. So I'm actually retrieving data from Coinbase. So first I define the relevant currencies that I'm actually interested in, okay? And I execute it, and I'm able to get the data. And here you see the retrieved data. So I have actually three fields: symbol, the name of the cryptocurrency, price information, and time information. Okay, this is how I get the price information. So if you remember, it was our end-to-end architecture, and so far we completed this part. In the next slides, we will complete entire architecture. Okay. So actually, here I show you have Atlas function. It is executed only once, right? So we need to execute this Atlas function many times because we would like to analyze all price information. So for this purpose, you can use schedule trigger. Schedule triggers in app services provides a way that you can execute your functions for every minute or every hour given interval. So here I give it a name. So first I provide a name for the trigger, okay? Then I choose the interval. So this function, actually I provide also function, this function is going to be executed every minute. So the thing is that Atlas provides a way that you can execute the functions for every minute, but my idea is that I need to execute this function for every few seconds, right? Because I would like to keep my data up to date. In order to do that, I did some trick. So actually it's a JavaScript code. I put a while loop, and in while loop, actually, I made the REST API calls, get the data, and sleep for a while, because we shouldn't abuse the API providers. Otherwise, we can get banned. Therefore, I was able to keep my data in Atlas cluster for every few seconds, okay, almost real time. All right, so it was our architecture, completed architecture, and we also completed schedule trigger part. So the next question is that how will we store the receive ticker data, price information? Time series collections. Time series collections has been introduced with MongoDB 5.0, and it's a specific collection type. So there is regular collection, and there is time series collection. It basically, the main feature of time series collection is it automatically organizes the time-based data. So if you have some events, it's coming every few seconds, few minutes, time bounded, then time series collection provides great storage, great performance. And for developer perspective, it's actually same as regular collection, because you don't need to consider the details. You don't need to focus on the details. Basically, you do insert operations or find operations as you do in regular collections. All the things under the hood managed by MongoDB. So in this demo, I'll show you how I create a time series collection. And I will insert a few records into the collection. And we will see time series collection and internal system bucket collection. So you might ask, what is internal system bucket collection? Basically, it's managed by MongoDB. You interact with the time series collection. Okay, under the hood, it's stored in a different way, and that is called a system bucket collection. So let's see this. So I connect my MongoDB Atlas cluster. Okay. And now I'm creating a time series collection. So I give it a name, crypto ticker Coinbase. Then I provide 3 fields in the time series part. So first, I need to provide what's the field name for the time. So I'm specifying that, okay, this is a time series collection. And therefore, there should be a time field in the data. And the field name is time, okay? And the second attribute I need to define is the meta field. So how data is going to be organized. Here I specify symbol, and it means that every symbol, every cryptocurrency is going to have own documents, and all relevant records regarding one cryptocurrency are going to be stored together, okay? And also I provide the granularity information. Basically, I specify here the ingestion rate, okay? Based on this value, automatically under the hood, the documents are going to be organized. Here I specify also another field, expire after seconds. Basically, I also provided after 3 days, this value actually a second value for the 3 days. After 3 days, the records automatically get expired, okay? So we create it, and now also we create the index based on symbol and the time field, compound index. And here I define 3 events, okay? 3 objects. And I do insert operation. And as you see, it's a time series collection, okay? And we do insert operation as we do in regular collection. So there is no difference actually. Let's check the all available collections. So here, there is one collection, crypto ticker Coinbase, that we created. And there is also another collection, system buckets, crypto ticker Coinbase. So let's check the number of records in both these collections. So as we expected, a crypto ticker Coinbase collection has 3 documents because we made 3 insert operation, right? We check other internal collection and we see there is only 1 record, 1 document. So let's check the records. So as we expected, crypto ticker Coinbase collection has 3 documents, okay? And the internal collection has only 1 document. So basically, time series collection allows storing time-based data in an organized, compact way. So therefore, instead of having many documents, it's automatically organized for your data. So here, for example, we made 3 insert operation, as you remember. And here there is only 1 document. Oops, sorry. There is only 1 document, but this document has all necessary events. And therefore, for the later processing, so if, for example, if you would like to access one cryptocurrency for a specific time range, you will access less number of documents, okay? And you will have less number of index records. So these all kind of things provides a better performance. So why time series collections? Actually, I try to explain, but I would like to repeat it because I also use regular collection before. I was doing this kind of analysis actually for a while. I even use some regular collection, but after time series collection has been introduced, I see great benefit in terms of performance. So all data regarding one cryptocurrency, one symbol, or it could be if you are doing some kind of, for example, vehicle tracking, okay? So all data regarding one vehicle can be stored all together. Therefore, later, if you would like to process this data, specific time range, then you will have actually efficient rates because all data is stored together. And you will have better compression because similar data stored together and compression works very well, right? All right, so it was our architecture. And we put also Atlas database cluster and time series collection. So, okay, how are we going to make insert from Atlas functions into time series collection? In Atlas App Services, there's a concept data sources. So you can access data sources from App Services application. Basically, you define data sources in your application, App Services application. So here I define my MongoDB Atlas cluster and gave it a name, MongoDB-Atlas, okay? And in Atlas function, I can access my data source. So here, there is an object context that provides functionality, many functionality. You can access data sources. You can make HTTP calls. Here, I use services method, and I provide a data source name. MongoDB-Atlas is the data source name, okay? Then I provide database name and provide collection name. And after that, I got the collection variable. I can do further operations. So I can make inserts, I can fetch data, I can update records, okay? So far, we actually completed the ingestion part, okay? So what we have done, we have Atlas function that makes REST call, get the data, and it is with schedule trigger. Every minute, the Atlas function is running, and in Atlas function, we make multiple REST calls and keep our time series collections up to date. So now, I will explain how I generate the candlestick charts. So here you see example data. Basically, for every 5 seconds, we have records, we have events, okay? And our granularity is second-based. But most of the time, financial analysts use data with different time resolution, okay? So it could be minute-based, it could be hour-based, it could be month-based, year-based. The reason is that instead of focusing on small time range, short time range, they would like to see the trend. okay? So candlestick chart, maybe some of you have already known, maybe some of you have already experienced it. I just want to quickly summarize what candlestick chart is. It's a representing price movement over the time, okay? So here you see an example of candlestick chart. There are two candlesticks, okay? And every candlestick represents one interval, okay? So for example, here represents 1 hour interval between 1 a.m. to 2 a.m. And this candlestick represents 2 a.m. to 3 a.m., okay? And every candlestick has 4 price metrics. Open price, okay? Close price means last price for the given interval, given time range, and highest price and lowest price. So as you see here, one candlestick, and this point is the highest price, represent highest price for the given interval between 1 a.m. to 2 a.m., and this point represents the lowest price for the given time interval, okay? So over time, you will have, of course, many candlesticks, and you can understand the trend, what happened in the past, and what might happen in the future. So, okay, I'm coming back to the point that we have second-based data here, okay? How I can transform this second-based data into minute-based data, okay? So I need to group this data, and I need to extract 4 price metric. Then I will have one document for every minute, okay? So let me show you. Okay, I connected my Atlas cluster here, and let's check some records here. So every 5 seconds, we have price data, okay? And now we're gonna group the data into different time resolution. So we use aggregation framework again, and in the first stage, I filter the data by specific cryptocurrency, Bitcoin, okay? And in the second stage, I group the data. So I group the data by the symbol, cryptocurrency name, and the time information, okay? So here I use specific operator that is available in aggregation framework, $daterank, that gets 3 fields, date, unit, and bin size. So date, actually you need to provide the time field, $time. I provide here the time field, the field name is time in my collection. And I need to specify the unit. So I have second-based data. What is my new resolution? So it could be minute, it could be hour, okay? And this is the bin size parameter is the length of the unit. So it means that basically I would like to group my second-based data into 1 minute interval. Basically, for every minute, I need to have 1 record, okay? And also I need to have 4 metrics, high, low, open, and close price. And for the high, I can use $max operator. For the low, I can use $min operator. For the open, I can use $first operator. And for the close, I can use $last operator. So these all operators are available in aggregation framework. After I group the data, in the last stage, I can sort the data by time in ascending way, okay? So let's execute this. And here, now, I have 1 record for every minute. So here, for example, 15:37, 1 record with 4 metrics, high price, low price, open price, and close price. And for another minute, 15:36, I have 4 metrics, high price, low price, open price, and close price, okay? So, of course, you can change the resolution. So for example, here, I change the resolution to 5 minutes. Every 5 minutes, I will have a separate document, separate record. Here you see that. 1650, I have one record. 1645, I have one record. All right. So technical candlestick chart part is completed. Now I'll explain how technical indicators can be implemented. So what is technical indicator in finance? So basically, it's pattern-based signals, okay? So based on the price, some signals are generated. Why financial analysts use technical indicators? Basically, they study past data, okay, and estimate the future prices, future trends. Examples, the well-known example of technical indicator is simple moving average, okay? So there are 5 technical indicators available in this MVP, this application: moving average, exponential moving average, RSI, MACD, and stochastic oscillator. So I will quickly look over these indicators. All right, so moving average. So moving average, for those who don't know, basically you analyze the data and you create multiple averages on the data, okay? Why it is used? Basically, reduce the impact of the spike of the price information. So rather than focusing on one or a few events, you can focus on the trend, okay? It can be used alone. So some people can use moving average alone, or some others can use moving average inside the other technical indicators. So for example, RSI is a technical indicator, okay? And internally, RSI is using moving average, okay? There are different versions of moving average, like simple moving average, exponential moving average. So let's see moving average in action, okay? If you already know, maybe it could be a bit boring for you, but I would like to explain this. So here on the screen, you see 3 cryptocurrencies: Bitcoin, Ethereum, and ADA, okay? And we will calculate 3 days of moving average for these 3 cryptocurrencies. So here you see the close price. So imagine that this is day 1, and these are the close price for these 3 cryptocurrencies, okay? And we would like to calculate 3 days moving average. So for the first day, we have only one record, and the average is gonna be that value, okay, because there is only one record. But for day 2, we will calculate moving average by considering these 2 records. So for example, we will sum up these 2 values and divide by 2, and it's going to be our moving average. And we need to repeat this operation for every available cryptocurrency, okay? And for the day 3, we have new record, and we need to consider right now 3 days of price, because we are looking for 3 days of moving average, okay? So we need to sum up these 3 records and divide by 3, and we will end up having moving average. For in day 4, so day 4, we need to discard the first day record, because we only need to consider 3 days of moving average, okay? And for the day 5, we need to discard first 2 days, because we are getting 3 days of moving average. So this is how you would calculate if you calculate this on paper, right? So this is the way how moving average is calculated. So how would you calculate the moving average in MongoDB effortlessly? Imagine that we have this data, 9 records, and the price is increasing by 1 every day, hypothetically, okay? And this is daily price. And we would like to get moving average, last 3 days of moving average for this input data, okay? So we need to have a new field in our data set, and it needs to represent 3 days of moving average. All right. So for this purpose, we can use a set window fields aggregation stage. Okay. First, we need to define the partition name. So how data is partitioned in my input stream. So every cryptocurrency needs to be calculated separately, individually. Therefore, it needs to be partitioned by a symbol field. Data needs to be sorted for every partition. So it should be sorted by time, ascending. And I need field name is MA3, okay? And it needs to be calculated with 3 records, okay? So for every record in the input stream, these 3 records need to be considered. So it means that actually here, okay, let's look at 2 previous documents and also the current document. Okay, 0 represents when the window ends, -2 represents how much you need to go the previous records. So here, basically, we are considering 3 records in our window. And it needs to be calculated for every record in the input stream. Okay, we specify here the window, right? What is our calculation? So we specify window, then also we need to specify, okay, what kind of mathematical function needs to be executed on this window. So we here choose $average. Basically, it provides average calculation for the given window. And average needs to be calculated on this field. The field name is close. And the average needs to be calculated on the close field for last 3 records for every partition. After you execute this, you will have a new field assigned a properly moving average. Okay? So on the screen, you see moving average with different parameters. So at the left-hand side, you see a moving average for the last 5 records. And at the right-hand side, you see moving average with the last 30 records. So if you notice that the blue line here, actually it's a bit small, it's not easy to see. Blue line, it's following the trend, okay? So because here, moving average 5 means that consider last 5 records and do the moving average. Because of that, it's very close to trend. However, here, we use moving average 30, and therefore it's capturing the trend a bit slower, okay? So financial analysts use different parameters for the moving average. Mostly, I saw that, I'm of course not financial expert, by the way, I'm just computer engineer, okay? They use 200 days of moving average, and if the current price is a bit higher than 200 days moving average, then it could be potentially a sell signal because it's really high. Maybe it's overbought. Maybe it's time to sell, okay? All right, so moving average is completed. Now, exponential moving average. So exponential moving average is a different kind of moving average. Basically, exponential moving average places more weight on the recent data, okay? So please look at this example. We have 3 days of records, okay? Day 1, we have 10, day 2, 11, day 3, 12. For simple moving average, for the day 3, basically we sum up these 3 values and divide by 3, right? So we end up having 11. Because there is no difference between day 3, day 2, they are all behaved equally. But for exponential moving average, recent data, like recent days, has more weight. Therefore, it's going to be closer, this exponential moving average, it's going to be closer to recent day price. So that's the difference. Exponential moving average is also used heavily, even alone or in other technical indicators like MACD. So how you can calculate exponential moving average? So here you see the operator, $exp moving AVG, okay? It gets two parameters, the field that includes numeric value, price value, and how many previous record needs to be considered, okay? So let me show you a quick demo. In this demo, actually, I will I will calculate moving average and exponential moving average for all of the symbols, cryptocurrencies in the collection, and load this data into another collection by using a $out aggregation stage. All right. So here again, we use lovely aggregation framework. First, we group the data for Candlestick, and here I actually specify 4 new fields, okay? Moving average 0.1, moving average 0.2, exponential, x moving average 0.1, x moving average 0.2. I have 4 new fields. And I specify necessary parameters, $average for the moving average and $x moving average for the exponential moving average. And I specify also the window, how many records need to be considered, okay? So after I execute this, the data is going to be loaded into another collection, moving average collection 0.1, okay? And that's it. So here, I have 1 record for every minute, okay? And every minute I have many metrics: highest price, lowest price, first price, last price, moving average values, and exponential moving average values. All right, let's discuss another technical indicator, RSI. RSI stands for Relativity Strength Index, and basically you measure the recent price changes and you evaluate that this asset is oversold or overbought, okay? How it is calculated? What's the formula of Relative Strength Index? I hope I will not bore you because it's a kind of mathematical things. First, you need to decide the interval. So you would like to analyze the data by daily or hourly, okay? Then you need to calculate the difference between current day and the previous day. So if you are processing daily, you need to compare current day with the previous day, okay? And if it is bigger than 0, it means that there is a gain, okay? Otherwise, there is a loss. So two variables need to be set. And after that, 14 days of gain need to be calculated, average gain. So you have gain and loss values for 14 days or 14 hours, depend on your interval. Now you need to get the average, okay? And divide by the average loss, okay? And you need to normalize the value between 0 to 100. Then you will end up having a numeric value between 0 to 100. So let's see this in action. So I will show this in the user interface. First, we choose a cryptocurrency, Bitcoin, okay? And we choose some interval, some filtering, date filtering. And we group the data by a 15 minutes interval, okay? Choose 14 previous data points. Hit the button Show Charts, and we see the Candlestick Chart first. And here we see RSI chart, okay? So here, as I mentioned, RSI is a value between 0 to 100. And the financial analysts evaluate that if RSI value is more than 80, this asset could be overbought. And if it is lower than 30 or 20, it could be oversold, okay? All right, so here you see the generated aggregation query. I will not deep dive all stages here. Just want to show a few things. There is an operator $shift that helps me to build RSI calculation. basically dollar shift provides a way that you can access in a partition in set window fields aggregation stage. Okay, you have partitions, and you can refer to previous records or the next records in the current data. So, for example, I had to access previous day records, right? So because I need to get the difference between current day or current hour, previous hour. How can I do that? So dollar shift provides a way that I can access previous or the next records in the partition. Here I put, it takes actually two parameters, buy and output. Here I provide -1. It means that check the previous record and get the close field, okay? I get the previous close price, and then I get the difference, okay? Then I do some arithmetic operation, divide bys, and the subtract operation, and then I have two new field, gain and loss. I need to run a moving average. So it's a bit complex, RSI, really complex, but actually aggregation framework here helped me a lot, okay? So I got the moving average for the generated field, gain and loss. Then I divide average loss, divide average gain by average loss, okay? Then I normalize the value between 0 to 100, okay? All right. So MACD is another technical indicator that is available in our MVP. Basically, it provides a way that there is a potential trend change. MACD stands for Moving Average Convergence Divergence. Basically, how it is calculated, what's the formula of MACD? Again, you need to decide the interval, okay? Daily, hourly, how would you like to process the data? Then you need to obtain exponential moving average for last 12 records and last 26 records, okay? It could be last 26 days or last 26 hours. You need to subtract these two exponential moving value. Then you will end up having MACD line variable, okay? Then you need to run another exponential moving average for MACD line. Then you will have MACD signal, another variable. Then you need to get the difference between MACD line and MACD signal. Then you will have MACD histogram variable. So basically, you will have three variables, okay? Three arrays of data. And you will show these three arrays of data in chart, okay? MACD signal and MACD line as a line chart, and MACD histogram as a histogram chart. So here you see one example. If a red signal is MACD signal actually, if red line cross the blue line, there could be potential trend change, okay? So for example, if red line is above the blue line, there is a price drop. Otherwise, there's price increase. All right, the last technical indicator is stochastic oscillator. So basically, stochastic oscillator, you compare recent price, the highest and lowest price in the recent past data. And after that, you will end up having a value between 0 to 100. Then again, you can evaluate this is overbought or oversold. Okay. Again, you need to decide the interval, daily or hourly interval. After that, you need to get the highest price in last 14 intervals. So if you decided daily processing, then you need to get last 14 days, the highest price in the last 14 days, and lowest price in last 14 days. Okay, you have two variables. After that, you did some arithmetic operation and end up having a value k. Then you will get a moving average. And after that, you will have two variables, okay? K and D values. So basically, you're gonna end up having a value for the K and the D values. It's gonna be between 0 to 100. And if the K value is, for example, more than 80, it's mostly known as it's overbought. And if it is lower than 20, mostly it's considered as oversold. Okay? All right. So there were some details, mathematical formulas. Maybe it's kind of boring for a while. So I just want you to think about the common features of these technical indicators. So I actually here provide 5 technical indicators. And there are dozens of technical indicators available. So the common features of these technical indicators are there are some math functions need to be run in recent data. Okay, so for example, the average price of last days, or highest price, or the maximum price, the minimum price, or standard deviation. Okay, so this is the common feature of technical indicator. You need to execute some arithmetic operation. So, for example, add two values or divide by each other or multiply by it or subtract. So you need to execute some arithmetic operation. And also you need to have some fields, extra fields. You need to store some values temporarily. So how MongoDB help here? Aggregation framework, a lot to build this complex calculation easily. So there are enough stages and operators that make this complex calculation easier. And time series collection helped me to have great performance on this complex calculation. All right, so here so far I explained how technical indicators would be calculated. So how I embed this logic in my app services application. So basically I have one main function in app services. My front-end application pass some parameters to this function, and all necessary calculation is calculated on the database level. And the data, the technical analysis data, the candlestick data is returned back to the client. So let me show you a quick demo about this. So these are all my functions available. And there is one Atlas function, main function actually. This is the function where my front-end application is calling. So basically my front-end application provides some parameters, okay? And I have sub-functions for every technical indicator, okay? So for example, I have another separate function for moving average, for MACD, for RSI, for Stochastic Oscillator. So I execute these sub-functions with parameters that is provided by client. So here, I will show you how I execute this main function. Basically, you can also run Atlas function in the console, okay? So here I provide some values. So I would like to get Bitcoin price for the last 3 hours, and the data needs to be grouped by 1 minute interval, and I have some technical indicators parameters, okay? After that, after I run this, I get the JSON data, return JSON data, okay? So let's see this JSON data here. I have 2 main fields, result and query. In the result field, I have all relevant data that my front-end application requires. So my candlestick data, moving average calculations, exponential moving average calculations, RSI, stochastic oscillator, and etc. All these calculations are there, okay? Front-end is going to call this function, get the data, and do some visualization. I have another main field, query. I also return the generated aggregation query for educational purposes. So you can also see what aggregation query has been generated and executed, okay? All right. So far, it was our architecture, and we also completed our Atlas function part. Okay. So here you see Atlas function. Basically, it is going to get parameters from front end and run the technical analysis on the time series collection and return back to the front end. So what's missing in this architecture? Actually, front end. So I built a React application, a React.js single-page web application. Okay, so you have already seen that it displays the candlestick charts and technical indicator charts, and it provides some rule management forms. I use Realm WEB SDK. So what is Realm WEB SDK? Realm WEB SDK actually enables browser-based applications like my React application or Angular application to access MongoDB Atlas app services or directly to data. So it provides access data that is in MongoDB Atlas. So in front end, you can execute some database queries without requiring a separate backend service. You can access the functionalities of MongoDB Atlas app services like functions. I show Atlas serverless functions, and you can execute Atlas functions in front end. It supports JavaScript and TypeScript applications. So how you can access MongoDB Atlas app services in React application? So first, of course, you need to install the library from Node Package Manager. Okay. Then you need to import the library, Realm-web. You need to provide ID of your application. So you create one application in app services, Atlas app services, and you're going to have ID. And you need to provide ID of this application in your React application. Then you need to authenticate your application. So here, actually, I use anonymous authentication. It's the less secure one. So basically, everybody can authenticate. But there are many options for authentication. You can use Google authentication, Facebook authentication, JWT authentication. After I log in, authenticate my application, now I can execute Atlas function. So for example, I have one function, name is getSymbols, and I can run this Atlas function in my React application. Then I got the result, and I can do further processing in front end. Or I can access a data source, linked data source, and then I provide a database name, collection name, and then I can run some database queries. I can fetch data or I can insert data without requiring a backend service. Okay? So it was our architecture, complete architecture, and we also here completed how client application is accessing MongoDB Atlas. All right, so this is the last part, hosting. So as I mentioned, we have a React application. So we have React application, React.js source code, and we compile the application. After we compile the application, we have a build folder like this, okay? So we can host this application locally or a server or whatever you would like to serve. However, there's an easy way to host this application. App services, static hosting. So basically what I did is I built my React application. Then I have CSS files, JavaScript files, images, and etc. I enable hosting in app services. I upload my files, and I have one URL, publicly available, publicly accessible. And therefore, I don't need to consider any other solution for hosting. So my hosting is also in app services. Of course, I need to, you can upload some static files like images or some other files, or you can also serve your entire application, as I did. I'm serving my entire single-page application in app services. So I just go settings of my application, and I choose the entry file index.html for my React application. Then I can serve my entire application with Atlas App Services hosting. So here we completed all architecture. All right, so how and what you can extend. This is my GitHub username. So there are 2 GitHub repositories. The first repository includes Atlas App Services application, okay? So you can actually pull the repository and follow the guidelines in README file, and you will have App Services application in 30 minutes, up and running application. That's simple, that's easy. If you would like to extend the functionality of the user interface, so for example, you might consider that, okay, I would like to introduce new technical indicators like Bollinger Band or some others, you can customize the React Web application. And there is also another repository for that one as well. So what kind of features you can add? I am also planning to add, okay? So I use the anonymous authentication, but if you are planning to have this application for production ready, you should of course consider more secure options like authenticating with Google or some other authentication providers, or even custom JWT. You can expand this application more exchanges. I have only 2 exchanges, cryptocurrency exchanges. You can also add some stock market. I am planning to add this. I have some access to some exchanges. Right now, there is no account integration. Basically, it's only, let's say, analysis, visualizing data. So there is no automatically buy or sell things. But Coinbase and Binance is providing, of course, keys, and you can embed this key, and you can, based on some price conditions, you can automatically trigger buy and sell actions. You can also implement paper trading. I don't know, do you know paper trading? It's basically, you can have some fake money, okay? So for example, you can have some fake $1 million virtual money, and you can basically, instead of having real money, you can work on this money. So for example, you make a commercial application, and you have some customers, okay? And after customer register, you can give him some fake money, and he can play with that money, okay? So I would like to buy this stock, this cryptocurrency, and sell it, and they can see their strategy, okay? They do right or wrong. Backtesting is interesting. I mentioned a couple of things regarding indicators. So for example, RSI, if RSI is more than 80, it could be overbought, okay? This is well-known things, but let's say you come up with a strategy, okay? I would like to test that. If RSI is bigger than 95 and moving average is lower than 20,000, what could happen? Okay, so you would like to test this with historical data. Then you can use backtesting. You can introduce more technical patterns, okay? You can also implement mobile application. I don't have it right now. And you can use, of course, Realm MongoDB. And you can synchronize some data between mobile application and the Atlas cluster. Like, for example, end user can have a mobile application and do some ordering. So, for example, buy or sell. And you can store this information first on the device, and it can be automatically synchronized with the cluster. And you will not be impacted if there's a connectivity problem. Automatically, it's going to be synchronized when a network connection reestablished. You can expose some data to third parties. So for example, you can end up having some kind of reports, analysis, and you might consider exposing this data to third parties through Atlas Data API. It's simple. With one click, you can enable REST API for your data. You can also consider adding more nodes on the cluster for analytic purpose. Okay, so if, for example, if you integrate more exchange and if you have, let's say, more users, you might consider putting more nodes for the analytic, and you can put analytic node in your replica set, and you can integrate Spark, for example, Spark. We have a Spark native connector, and you can run even some machine learning models on price data. And you can also consider archiving some data to online archive, because it's a time-based data, and after a while, you might consider that the old data is not necessary, but you would like to access some time, not all the time. Therefore, you might consider online archive. All right. So today in this session, I walk you through how I develop an end-to-end application to analyze financial market data, especially for the cryptocurrency. And I use many capabilities of MongoDB Developer Data Platform. In front end, I use Realm WEB SDK. In back end, I use Atlas Functions, Schedule Trigger, app services authentication, and app services hosting. And in database level, I use Atlas Cluster, time series collection, windowing operations, and aggregation framework. So if you don't have a MongoDB Cloud account, just visit cloud.mongodb.com, pull these two repositories that I shared, and start testing it. Any questions? Yeah, that's okay. Let me repeat the question. So the question is that there's a chart on the web page. It is automatically refresh or not. So basically, I don't have that capability yet. So it's not yet automatically refresh. There was another question. Yeah.
Do you know of any real-world examples that could be using this architecture? Or are you aware of any limitations that would be preventing any real-world application, like in performance and any lock-in to this?
Okay, yeah, that's a good question. Thank you. So, so far, I can't see any reason that can prevent this application to be operated for thousands of people concurrently, because I did some tests. I had, I think, 3 billion records in my collections, time series collection, and I was able to get the technical indicators data in 1 second. So for the database there, I can't see any bottleneck. And for the Atlas App Services part, it's also a high available, scalable part. I can't see any reason that can prevent this application to be accessible for a huge number of concurrency. Sorry? I haven't faced. I use necessary indexing and the proper, of course, the collection, time series collection helped me about this. I didn't see.
So when you define the time series collection, you didn't put all the field. You do not have to put all the field, right? That you're going to put only time and windows and stuff like that, right?
Exactly, yes.
Okay.
You don't need to specify the measurements, the numeric values. Only actually it's required to provide time field. I also provide, it was optional, the meta, how the data is going to be organized. So for every cryptocurrency, it's going to be organized, and therefore I provide a symbol field as a meta field in time series collection definition.
But like other collection, you can always add more field, right, without changing the metadata.
Of course.
Got it. Thank you.
I'll go to this one, I think.
Could that field be organized by multiple properties instead of just one symbol field? Like combining multiple fields to make a unique.
So you mean that multiple symbols? I didn't get the question. Maybe, yeah.
If you had an instance where you didn't, like in this case, the symbol is a unique field and that made sense, but what if you had a document where it wasn't just one unique field like symbol, but you needed to concatenate multiple fields to get that uniqueness? Like, is that possible with a time series collection?
Yeah, in time series collection, yeah, you can, of course, define an object for the meta, so it doesn't have to be on the field, so you can have an object as well, yeah.
You built a very nice application. I have one question. Have you run into any performance issue since you are dealing with the large volume of the data?
Okay, so I was actually using M50 Atlas cluster. As I mentioned, 3 billion records, and I was able to retrieve data in 1 second. Of course, I used proper indexing and proper, let's say, the time series collection, of course, helped me. And while you define the time series collection, it is important to specify proper ingestion rate in the granularity part. So far, so good. Yeah, welcome. Yeah.
In Python, they have a time series analysis. Have you used the same time series analysis on the MongoDB also? Because in the Python language, they have a time series analysis. And I have seen a lot of people, they have worked on Python and they did those time series analysis, especially on the stock market. So are you using the same functionality or this is a different functionality which you work on the MongoDB aspects?
Okay, actually I'm not aware of that functionality in Python. Maybe it's application level kind of processing.
Right, and it was a very good presentation. Thank you very much.
Yeah, thanks. Welcome.
Anyone else?
Like everyone said, it was amazing. This was my third session on time series, and yours is the one which has covered all the aspects that I was looking for.
Thank you.
A follow-up question about the performance part that he asked. Do you have any specific numbers in terms of performance? Because time series data tends to increase over time, and it can go up to TBs easily.
Yeah.
Do you see any performance lag once we have a lot of data?
Also sorry? Okay. Yeah, sorry. So as I mentioned, the Atlas Data Lake and the online archive can help you here. And the proper indexing and the defining time series collection also will help. In this application, I haven't seen yet any performance drawbacks. Of course, the query design is also important. I also filter data properly. If you check the aggregation query, generated aggregation queries, you will also see that how I use aggregation framework. That is also important. How you can utilize the indexes. Yeah.
Okay, we're just about, you want to do one? Let's do one more. Okay, we're going to sneak it in. Let's do one more.
With billions of data points, how do you do the sharding? How do you choose the shard key?
Sorry, Chelsea. Yeah. Oh yeah, that's a good question. So imagine that if you have huge amount of data, how would you design the sharding? So I think here, shard key, it depends on the query, of course. While we design sharding architecture, we mostly analyze the query shapes. But in this example, I would choose the symbol as the shard key. Therefore, I can have, for example, imagine that you have multiple shards, 3 shards, and each shard has its own cryptocurrencies. But I assume here that all cryptocurrencies behave equally. So if there are some critical cryptocurrencies, maybe it's queried more than the others, then you might consider time-based, and you can combine symbol and time field in the shard key.